Hi, this video is going to cover alcohols from the OCR A Level spec. We'll look at the properties of alcohols and also the different reactions that it undergoes. So combustion, oxidation, elimination of water and substitution reactions. So to start with some simple properties. And I'm just going to draw ethanol out for us here. So this is an alcohol. It's got two carbons, so F, single bonded N, and then the alcohol group gives us the suffix OL or ol. So in this we've got O, that should have two lone pairs on, and really electronegative atom oxygen. Hydrogen, not very electronegative. So what we have here is a permanent dipole form. So a delta negative oxygen and a delta positive hydrogen. And that means all sorts of things with the OH. It means, one, it will with other ethanol molecules. If we had for ethanol over here, it will form a hydrogen bond. So when you have ethanol, they all form very, very strong hydrogen bond to another. So hydrogen bond from the lone pair to the electron deficient hydrogen. Just get the dipoles on here and the lone pairs. So we get very, very strong intermolecular forces. In terms of intermolecular forces, hydrogen bonds are very strong, holding together the ethanols. So that means that they are, first of all, they have what we say low volatility, or difficult to get to evaporate, volatility, or high boiling points, because relatively high boiling points, because of this strong hydrogen bond that holds them. It also means they're soluble in water, because they'll do the same thing with a water molecule. They'll form a hydrogen bond with a water molecule, and then that just means they dissolve within it. They can get in between the water molecule atoms and be held there. So they dissolve in water, so they're soluble in water. I can't remember if we need to cover any other properties. Solubility, low volatility, yeah, compared to alkanes. Brilliant. Okay, we have three types of alcohols. We have primary, secondary and tertiary. So a primary alcohol is one we've just seen. I'll draw this slightly differently now. So we have our OH group on a carbon, and the carbon is bonded to one other carbon. So this is our primary. We see our alcohol carbon, that is bonded to one other carbon. Our secondary, breathe that to CH3, is bonded, our carbon is bonded to two other carbons. So this is secondary. And a tertiary alcohol, you probably guessed where this is going. It's bonded to three carbons. So this is our tertiary. If we next look at some of the reactions. And the first one, similar to alkanes, we look at combustion and the same reaction occurs. So it's C2H5OH, the formula for ethanol, plus O2. We get complete combustion, we'll go to CO2 and H2O, and then just balancing it, we've got two carbons on this side, so I needed two there, 6 hydrogens here, so I've got 3 there. That gives me 4, 5, 6, 7 oxygens on this side, so I need a 3 there to get up to 6, and I've got the 7th oxygen there. So just often people forget that oxygen's there, and would have put 3.5 there to get it to balance. So that's combustion. Next up, oxidation. Now, oxidation is probably the most important reaction you'll look at when it comes to alcohols. And in oxidation, when we oxidize different types of alcohols, we get different products. So a primary, when it's oxidized, will first of all go to an aldehyde, and then it will go to a carboxylic acid. I'll take my ethanol again. I should draw the structure out really. So we've got our carbon, we've got OHs, and what we're going to react this with is acidified potassium dichromate. So Cr2O7 minus 2 minus ions in an acid environment. So you could say that that's potassium dichromate is the common one with HCl or H2SO4. H2SO4 probably more likely. But you can also get away with just abbreviating it to the dichromate ion plus a H plus ion. And that, first of all, will go to an aldehyde. In this case, ethanol. Now, if you carry on with this reaction and keep on heating with the acidified dichromate, you'll then turn this into a carboxylic acid. That's if it's primary. If it's a secondary, this time I'll have to do propanol, and propan-2ol. So it's on the second carbon. So this carbon's attached to two other carbons. I'll draw my methyl group the right way around. If we add acidified dichromate to this, we get a ketone. And I've made a mistake. There should be a hydrogen there as well. Carbon needs to bond 4 times. So forgetting that, I only had 3 bonds there. That hydrogen goes, and this oxygen becomes a double bond and loses its hydrogen, and we get this, which is propanone, sometimes known as acetone, and that is a ketone. So we get a ketone forming a tertiary alcohol. If we try and oxidize that, we get no oxidation. There's no space to add anything onto. You see on this one we lose a hydrogen, and instead of having the hydrogen bond we get a double bonded O. We can't lose a hydrogen from this. We've just got these strong CC bonds. Up here we lost a hydrogen for the OH. Over here we lost one of the hydrogens to form a double bond as well. There's no space for that in the tertiary. So we get no oxidation if it's a tertiary alcohol. And similarly, we can't oxidize this any further. So this ketone here, once it gets to this stage, there's no more oxidation. So that can't go then into anything further like the primary did. It went into the carboxylic acid. Next up is the elimination reaction. And we're going to eliminate H2O. So what happens in this reaction is we take our alcohol, I'm actually going to draw this properly, and if we react this or add to this H3PO4 or phosphoric acid and heat it, what happens is we lose an OH from here and a hydrogen from the other carbon. So it's coming from the carbon on the other side. And that leaves us with a carbon with just 2 hydrogens on either side. And this should look familiar. This is the basic point of alkenes. So we've got there an electron and a p orbital here, electron and a p orbital here, and they overlap to form that pi bond. So we get an alkene forming here. And we also get H2O given off. So this is why it's known as elimination, because we had a compound up here, and our products, we've removed that H2O. We've eliminated it from our initial and nothing else has been added on to the initial. We've just eliminated something. Final one is a substitution, which is nice and easy. What we have here, again, I should stop rubbing now, this ethanol, is we're going to add some halide ions, let's say Cl minus, and in the presence of sodium bromide and H2SO4, catalyst, and the substitution is between the OH and the Cl minus. So we get a haloalkane where the Cl goes where the OH was, and the OH comes off, and now that's got to be OH minus. We had a negative on this side, so I'll need to balance that by having a negative on this side. So we get the hydroxide ion given off, and they've just substituted around. If we make a nice quick little synthesis map for this, if you put your alcohol in the centre, we've got our different reactions. We've got combustion plus O2, we're going to get CO2 and H2O. If we take a primary and add H plus and Cr2O72 minus, we're going to get an aldehyde if it's a primary, and if we carry on going, we'll get a carboxylic acid. If we take a secondary and do the same reaction, then we're going to get a ketone. If we add H3PO4 and heat, we're going to get an alkene plus H2O. And if we add Cl minus with sodium bromide and H2SO4, oh sorry, sodium chloride, leave that one there, then we'll get our haloalkane. Plus hydroxide. Hydroxide is OH minus. We just swap it off. So there are the reactions of alcohols.